Well, my name is Michel Doidic. You may have noticed, but I'm French. It's okay. I've been in the US for more than 45 years now. I came in 1980 or so from France, clearly, where I was working in at a distributor which was actually distributing Oberheim for France. So that's where I got to get in touch with the product and eventually with Tom. And since I was really interested in getting into this field, I thought it would be a good idea to go to work over there because in Europe there were some stuff, but not nearly as exciting as ARP and Oberheim and Moog, of course, and so on. So there was a chance, and I did that, and it was fantastic. I learned a lot of stuff over there. My first job, I came for vacation officially, and I ended up spending 2 weeks at Oberheim to get a feel for the place. And I did printed circuit, which were done back then, not computer. It was little black trace that you put on a transparent film and it shoots with photo and everything. And I did that, and apparently I did okay. So I said, "Can I come back for a job?" And Tom said, "Sure, we'll see what we can do." And so I came back. I'd done a lot of modification on Oberheim synthesizer when I was in France, because there were some stuff that they couldn't do, and I was interested. So I did something, and I think Tom saw, oh, maybe that's interesting. Maybe it can be useful for something besides printed circuit. But when I went there, I didn't know anything about microprocessors. This was still very new back then. So it was definitely a culture shock to get into that, but it was great. So the OB8, my main contribution on this guy were two things. One was to do the auto tuning. There was no tuning, if I recall, on the previous machine. You had to do it by hand. So if everything was calibrated perfectly in the machine, that was okay. But if there was anything which went slightly out of calibration after the factory initial setup, the stuff would not track perfectly, and there was inconvenience. However, the Curtis Electromusic, the chips were really good. They were extremely stable, so you could get by with some deviation. It was still okay, but still it could get slightly off of tune. I was unknowing. So one of the first things I did was to create a software feedback to actually tune the oscillator, but not only for one note, but for the whole range of the keyboard. And that worked really well. In fact, it worked too well, because when we got it to work, it was so perfect that the machine was dead. The oscillator were exactly in tune, no beating whatsoever, and it's like having one oscillator out of two, or even if you were to put it in monophonic mode, it was like having one gigantic oscillator with no beating, so it was completely dead. So the first thing we had to do was to add a knob for detune, so you could get back to something which was more lively. But at least you could get it back in tune or not in tune, whatever you wanted. So that was one thing I did. And then the other thing I did for this one was the modulation box, which is again with a little lever here, was a bit of a nightmare on the previous version. I think there was something like 10 trimmers to get the offset right, the tracking right, and it was difficult to calibrate and expensive to do, and so on and so on. So there was an opportunity to actually do it with a microprocessor on this machine. So we did that, and that made the stuff much simpler and much more stable, and you could actually get more feature. We were able to add different wave shape, like square wave with, I don't remember, but it was doing more, and it was much easier to manufacture, so that was good. And of course, when you start to put your finger into this kind of idea, it's like, oh, if I can do that, I can do this. And so that's kind of where the expander and the Matrix-12 kind of got their beginning as far as what can we do, which is a little bit more interesting than we have been doing before. And there was also, I believe, the portamento, which was on the previous version, was a real complicated, expensive to make circuitry. And so we did that in digital too. And the funny thing about it is that there's a feature which is called the quantized portamento, where instead of going smoothly from one dot to the other, it goes by semitone. So it goes ta 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 ta. It's good. And this is a mistake, because when I was doing the code, at one point I was loading the DAC, which was made of 2 bytes, and I forgot in the code to load the lower part of the DAC. So instead of going smoothly, it would go only on the upper part, which happened to be semitone. So it was a pure mistake. We said, oh, that's kind of cool. So we added a switch on page 2 to do the quantized portamento, which was used in some record. I don't know which one, but it ended up to be a feature that some musicians like. So sometimes errors are kind of good. I'm coming to synthesizer more from the engineering side than the musician side. I'm not a musician. I can play guitar, but it's embarrassing to even talk about that. So for me, synthesizer from the very beginning were interesting because they were machines you could experiment things with. And I got my teeth first on the EMS synth, which was this little carry case, which had a matrix with pin where you could do essentially cross modulation, just like you do with a modular synthesizer, but instead of using cable, you use little pin. And this machine was perfect for experimentation because you could connect anything to anything, including the audio path. So to me, this was what I liked about synthesizer, trying new things, see what happens if I send the VCF output into the envelope, which you can do. It doesn't do much, but you can. And so once in a while, with I would say more luck than intelligence, you get something, oh, that's really cool. And I like that. So that was really my interest. And at the same time, in the 80s, microprocessor became powerful enough. They are incredibly weak compared to what you can do today, but they still became powerful enough to be able to do these kind of things with digital generators. So you could do envelopes in digital, you could do LFOs, you could do portamento and all sorts of things. And so it was kind of a nice coincidence of wanting to do something a bit more esoteric and letting you do more original stuff and the technology allowing you to do it. So we had to go to a more powerful processor because the one on the OB8 was a Z80, which didn't even have a multiplication. You couldn't do multiply. You had to do it by hand, essentially, which was very slow. And so we went to 6809 from Motorola, I believe, and that was much more powerful. Probably 100th of the power of what's in your watch nowadays. But nonetheless, that was enough to do this kind of stuff. So that was a fantastic convergence of technology and interest. And I was lucky enough that Tom let us work on that because it was an expensive project to do. It took a while, and I hope some people enjoyed it. One of the things which matters a lot to me when you listen to acoustic sound, real sound, there is an amazing complexity in real sound. If you take the simple case of a guitar string, you cannot get the same sound twice in a row by plucking the string because there are so many parameters that you cannot really control. And it may not be a big difference, but it's never twice the same. And so that makes the sound interesting to us because I think our brain is craving complexity when it comes to sound. The more complex the sound, as long as it's still musical, the more our brain gets tickled and interested by it. And synthesizer, especially at the beginning, were really not going that way because they are very systematic machines which do always the same thing and have limited number of parameters. So it was interesting actually at the beginning because they were so different. They were really not acoustic. They had this kind of electronic, new age, very deterministic sound. But in the long run, I think acoustic sounds are still interesting. So to get a sound which is interesting to me, you have to have complexity into it. And so complexity can be the wave shape itself or can be how it evolves in time. So with a lot of modulation source and way to make them go crazy back and forth and modulate the envelope by the LFO and modulate the LFO by a tracking generator or whatever it is, you can create, at least get closer to something which has some variation, some not quite expected change in time. And that's, to me, that's more interesting. And of course, you can do a lot more of that nowadays, but this was a good way to start. Now, you could do that with a modular synthesizer because as long as they have the input, you can put cables wherever you want or little pins. But that kind of went out of the window with polyphonic synthesizer because you may have, a big panel with 20 cables for one voice. You're not going to do that for 12 voices because it would be crazy. So polyphonic synthesizer clearly were nice because it's polyphonic. You can really do real music with it, or at least harmonic music. But they had to be simplified so that you could keep things under control. And this one was able to get a little bit of both. So I like that. The processor, as powerful as it may have been back then, could not do everything. So we had to limit it to something reasonable. I don't know. I think what happened is that you and I spent a lot of time of arguing. It was a lot of time arguing about what was best, especially about this button, the store button. I think we moved it just all over the place, and it was funny because I would leave in the evening and I would decide on the mock-up panel, to put it maybe here, and then I would come in the morning and it move back here. And then so it just went all over the place. That was the easy bit, but we had lots of friendly argument about what's best to do about this and that and that. But eventually, that's what we settled on. There was no real reason why there should be 5 or whatever. I think it was mostly a matter of limitation. There was also a limitation because the way the software is running. One of the big problems with this machine was it was very demanding on the microprocessor. So we had to find ways to make it run fast enough. And the way we did that is, it's kind of strange, but when you change a parameter on the front panel, what it actually does, it changes the program, not only the parameter, but it changes how the program unrolls. It changes the sequence of operation that it does in function of what the front panel is doing. That speeds up things a lot. But the problem with that is that you have to have a lot of memory because you have to store this intermediary step, and that takes a lot of memory. And memory was expensive, and Tom was not going to go crazy on it, which is right. So, the more envelopes and the more stuff we were putting, the more memory we needed. So it was kind of a limitation. But I think 5 envelopes. I think it's enough. The name is my birthplace. Why? I have no idea, because I remember we were in a meeting and we were arguing what sound should be included in the preset. And originally we were going to go for the classic Oberheim sound, the brass, this, and then some people say, well, maybe we should put something a little bit newer into it because we can. So we say, okay, we'll pick this one. And they ask me, what name do you want to get? I have absolutely no idea what name. What do you mean the name? I have no idea what should. So Saint Genevieve, what the first thing which comes to mind. It has really no logical connection. But to be fair, it's heavily inspired from Tomita. It's a very Tomita kind of sound, and so I cannot take all the credit for that. I think he pretty much created those kind of sound well before. I'm glad it's used. It's nice. Well, I remember a conversation with Doi actually, which was funny for me because when we started to do envelopes with software and LFO and those kind of things, he came one to the lab and said, "Oh, this is really impressive. I'm really impressed that you can do that." And what I was thinking on my side, this is the easy bit. What he's doing is the difficult stuff because I have no idea how to make a VCO which is stable in temperature and everything, and then put it into a teeny little chip and make it affordable. So it was like he thought what I was doing was great, and I felt like this was comparison the trivial stuff. So that's kind of funny, but it was great to work with because you could always say, well, could you do the chip so it does that? Oh, okay, look at, and then he will bring those prototypes which were unbelievable because he did prototype them with discrete transistor and resistor and capacitor before they got integrated into an IC. And he brought one, and it was a ball of component about that big, complete. It was essentially like I don't know, a bird nest of wires and transistor, and I don't even know how he could manage to get to one of those things, but that worked somehow. And so when he got that to work, he would go and integrate it into an IC. And I was really impressed that he could get this stuff to work. I was very impressed that he could actually bring it from Northern California to Southern California without the stuff breaking because it was just crazy. It was really amazing at this kind of stuff.